Well, thank you for joining us on exercise 2A. I'm going to be looking at question 4, and this is to use calculus techniques to determine the exact coordinates of any stationary points on the following curve, which is y equals x cubed minus 9x. Now it's a cubic, which happens to have maybe 2 or maybe 1 turning point, or maybe none, because it could have one. A cubic could have one, or a cubic could have no turning points whatsoever. So it doesn't quite level out. So this is an oblique inflection, this is a horizontal inflection, and these are two stationary points. So let's get dy dx, and we get the stationary point. The first stationary point is when dy dx equals 0. So the derivative will be 3 times 1 is 3, x to the power of 3 take away 1 is 2. And then we've got x times x to the power of 1, so it's 9 times 1 is 9, and then it's going to be x to the power of 0, which is 1. So 3x squared minus 9. Solve that equals to 0, and we will bring the negative 9 across to be positive 9. Take that divide 3 across to be divide 3. Therefore, x squared equals 3. Therefore, x equals plus and minus square root of 3. So it's happening. There are two stationary points, negative root 3 and positive root 3. So when x is negative root 3, y will equal negative root 3 cubed minus 9 times negative root 3. So we get negative 3 root 3, or negative root 27, and a negative, because negative times a negative is a negative. Now two negatives make a positive, and this is 9 root 3. Well, that makes altogether 6 root 3. All right, so there's one turning point, and the other turning point is when x is positive root 3. So y is root 3 cubed minus 9 root 3, which is 3 root 3, because root 3 times root 3 times root 3 happens to be root 27, right? And root 27 is root 9 times root 3, and square root of 9 is 3. So however you look, whichever way you look at it, root 3 cubed is 3 root 3, take away 9 root 3, and that leaves 6 root 3. Is that right? Negative 6 root 3. Okay, so we've got two turning points are negative root 3, 6 root 3, and positive root 3, negative 6 root 3. And to test this in our second derivative, let's get our second derivative. So d2y dx squared will equal, there's the first derivative. So 3 2's are 6, x to the power of 1, and 9x to the power of 0. 0 times 9 is 0, so it's simply 6x. So we test first, x is negative root 3, therefore the second derivative is going to be 6 times negative root 3, which is negative, therefore concave down, and a concave down stationary points is a maximum at negative root 3, 6 root 3. Now test when x is positive root 3, therefore our second derivative will be 6 times positive root 3, which is a positive, therefore it's going to be concave up, and concave up curve is a minimum, so there is a minimum at root 3, negative 6 root 3. I hope this has helped. Until next time, stay happy.